morning, everybody. We're going to be going through the lab today and looking at different water samples that go with our fish kill or an aquatic apocalypse. So in the first one, we have 3 empty beakers that are filled with distilled water. They're going to be labeled salt, sugar, and oil. And then our fourth one is going to be the river water, are the 3 that we have. So in the first one, it says oil is a nonpolar hydrocarbon. It says add a few milliliters of oil into the 1 beaker of distilled water. We want to describe what we see. How can we tell that this is a nonpolar molecule? We're going to use the glass stir rod to stir it in to see what's going to happen as the oil appears. Does it mix? Is the oil still visible? What can we see happening? So here is our oil in our dropper, and we're going to add some oil to our water. And it's not colored, but there's some bubbles on the top of the water that are the oil. If we were to stir it in, so the oil is right here floating on top. As we stir, we still see the oil kind of separated in there. There's our oil and the water. So describe what you see. So what can you see in the water right now? How can you tell that this is a non-polar molecule? And remember, water is a polar molecule with a partial positive and the partial negative. We use the glass stirring rod. What happens when we stirred it? So what appears now? Is the oil mixed in? Is it not mixed in? Is the oil visible? What do you see? And we'll kind of set this aside and then see if anything else happens or changes. Next, we want to test some polar molecules. So polar molecules are something that dissolve in water. They have partial charges. So we're going to add a scoop of sugar to the second beaker, and we're going to stir it into the water and see what happens. So here is our sugar. We're going to add it to our sugar beaker here and see what happens. Okay, so you can see kind of it's at the bottom right now. If we are to take our glass stir rod, so there's some that's kind of at the bottom. It's not all visible. You can see some of it right here. So as we stir the sugar into the water, what is happening to the sugar? Do you still see the same sugar visible in the container? So the sugar has dissolved into the water. It is mixed in. So it says what happens. It is dissolving. So it's mixed with the water now. It's a mixture. Water is called a universal solvent because it dissolves more substances than others. Than another. If a solute, like sugar or oil, dissolves in a solvent like water, it's considered to be soluble. That means it's going to dissolve. So here, the sugar and the water are soluble because they mix together, while the oil and the water are considered insoluble because they do not mix together. Next, we're going to test an ionic compound. So add a scoop of sodium chloride to the third beaker, stir the water. What happens to the salt? Is the salt soluble or insoluble in water? So here we have our salt. We're going to add our salt to our third of water. Going to add a scoop of salt. You can kind of see some at the bottom right now. And then we're going to stir it with our glass stirring rod. So here is it unstirred. Kind of a little translucent. It's gone away some already. So as we begin to stir it in the water, okay, so it was at the bottom, lots of granules. So this, does it dissolve in water? Do you still see it? If you do not, then yes, it does dissolve in water. If you still see something, then no, it does not dissolve in water. When a soluble ionic compound is combined with water, it dissociates into its ions. So the sodium, because the sodium ion +1, chloride becomes a -1 inside the H2O that is in this container. So because of the separation of charges, solutions with dissolved ionic compounds are like electrolytes. They can conduct electricity. Non-electrolytic solutions do not conduct electricity. Covalently bonded, such as the sugar that we have here, do not ionize in water, and thus they do not form electric solutions. So we're going to use the conductivity tester to test our salt solution and see what we see. Is it electrolyte or non-electrolyte? So we have our system over here. We are going to use to test. So it's zeroed out currently, and then I'll show you guys what it comes out to. So as we add our conductivity meter into our salt solution, there's not much salt in it, so it might not be very high. 0.99. It's changing frequently. So that's 7.5. So there's some charge that's popping up 0.99, and I'll show you guys in That's measuring the electricity that's running through it. So it changes, since there's not much salt in here, it changes pretty quickly. So it's measuring the conductivity within this salt solution here. So that one is saying that we have electrolytes in it. So it's lighting up as electrolyte. We wash it off. We're going to try the sugar solution and see what we see. So with our solution, we will take our deionized water, rinse it off, make sure we don't have any of those ions still on it, and then add it to our sugar solution. So here is our sugar solution. As we add it, there is no change occurring. So 0.00 on our conductivity meter. Now we're going to look back at the oil and water. Have any changes occurred? We're going to add a few squirts of soap and see what happens. So here is our soap, and we have our oil now. Look at it before we add our soap. There's still the droplets at the top. So as we start to add our soap, and the soap is kind of a yellow color too, we'll see kind of what is going to happen to our oil mixture. Ooh. So some is on the bottom now. Some of the oil has dropped to the bottom. we stir it, okay, a little cloudy maybe, but the oil looks to be breaking down on the top. Like we see some bubbles now, but not really oil, that's just from the soap. There's teeny tiny little oil, like dots on the surface. There's not the same large oil droplets that are appearing that there were. After watching the video, so you're going to watch a video and see why the soap cleans the oil. What is, like, is it polarity? What properties does it have that make it do that? And lastly, we're going to look at a river water sample of the fourth beaker. If we were to smell it, so we like waft and smell, think about like what the lake smells like. If you're at Lake Kauai, or in general, like rivers smell a little different. They might have like a little musty smell a little woody, or some it might just smell like dirt, but it has a different smell than just pure water. So describe the color. Is the water sample turbid? So are there things floating, or is it clear when you're describing the color? So here, is it a clear substance, or are these things floating? And let's see if we can, there's little chunks that are floating by. They're like a dark brown color. So this one has like a medium turbidity. Like you can still see through it some, but not much. Like if I were to hold up like this dark blue behind it, you can't really see it. Versus if I were to hold it up behind this one, we can see it. So that one is turbid. We're going to test it in the conductivity tester and see what happens and what it's going to tell us about the water. So we'll turn on our tester again. And it's all cleaned up with our DI water. And we're going to test our river water sample. Okay. And we go into our sample, zero it out. 99.9, 48.2. And you can kind of see stuff swirling around in here. 0.6, so it kind of changes, roughly around 40, so it's saying that there is stuff present. So there are like electrolytes present in our river water. Whereas you put it in just the DI water and it comes out to 0 again. So that one is saying that it has electrolytes, so it's lighting up. It's saying like 40, there's energy passing through it. Do you see any signs of oil in the water? What do you observe if the oil is present? So here we have our oil mixture. Do you see any oil present here? The bubbles on the outside are from the soap. So is there oil present? I don't see the same little bubbles that were there before in the oil and water mixture. And then we're going to watch a video and explain fluctuation. In future labs, you'll use the river water samples that have been fluctuated. What will have been removed from those samples? What does fluctuation mean? What does it never remove? Answering those questions after you watch the video. And then on the last page, you guys will look at some pollutants and determine what those pollutants have. Polar ionic, polar covalent, nonpolar ionic. Are they soluble, not electrolytic, or not electrolytic? On the last page. And that is your lab for today.